All right, you guys, we're going to learn about our surface currents, our ocean surface currents. And just really quickly, I've briefly, or just slightly drawn in some of those major wind belts. So if you remember, these are my northeast trades, these are my southeast trades, these are my westerly winds. And what I really want to tell you guys about why it's so important to understand these, first of all, these are going to greatly influence my ocean currents. It's wind blowing over the ocean surface that makes these surface currents. But second of all, just to let you know, let's pretend that you were an early explorer. You're from England, okay, or you're from Spain and Portugal. So you're over here and you want to go explore the New World. And what you would do is you would want to grab these currents and wind belts. Now, you can't do this. You can't go this way. That's not very smart, especially when you have just a sailing ship, a ship that's sailing. What they would do is they would kind of drift down this way, and then they would catch this across. And this is not only a wind belt, it's also a current. And then there's also a current that's going to come up here. And so the early explorers, they'd start here, they'd come down here, they'd do some exploration along the way, okay? And then they would catch the westerlies back home to Europe. So kind of cool. I like this sort of stuff because I really like history, and history kind of depends on what's going on with the Earth. All right, now what you want is you got just a little thing that's good for you. I can't help myself. What you want is this, and I would download a couple of copies. Now you guys, I have 3 different colored pens and pencils, and so I'm going to talk to you about the currents, and the different colors are going to represent different temperatures. Okay, but if you don't have colored pencils, you can do it with a solid line, a dotted line, and a dashed line or something like that. But you are responsible for the different names and the different the different temperatures of these currents. All right, so we're going to start with kind of the easy place, you guys. We're going to start with the equatorial currents. And obviously the equatorial currents move along the equator. And so what we're going to see, and I'm only going to make these are called the subtropical gyres, and I'm only going to make these gyres right here. And remember what a gyre is. It's a series of 4 currents that circle the large ocean basins. And if you guys remember, we talked about the Coriolis effect. It's going to come into play here. The wind belts and boundaries, these equatorial currents are driven by my trade winds. So if you remember from that last shot, we've got the southeast trades coming up like this and the northeast trades, and that's what's creating. And these are, again, called the northern equatorial current. Okay, and now we can and this is, guess what? Northern equatorial current. Not a whole lot of words. And this is the southern equatorial current. Now, you guys, we've got to deal with the Coriolis effect. These ocean basins, the water's going to pile up. So yes, sea surface elevations on this side of the Pacific Ocean basin are much higher typically than on this side. And so when you pile up water, it's going to move downhill. Think about it. If you guys make a pile of water, it's going to move downhill. It wants to become even. Now, what it's going to do, and it's moving downhill, is going to be affected by the Coriolis effect. Okay, and so it's going to make a right turn here and a left turn here. Okay, and a right turn. Remember why right? Because we're in the northern hemisphere. All right, now this is kind of cool. This current has 2 different names. These are called the western boundary currents, and they're kind of some of the most exciting currents. They're the fastest currents. They are the most studied currents. This is the Gulf Stream, and that is the most studied of all of our currents. Okay, it doesn't hurt to be off the coast of Woods Hole Institution of Oceanography. Now, this one is called the Japan current, you guys. Think about it. It's pretty easy. It runs right off the coast of Japan. Now, if you've ever been in Japan during the summer, if you've ever been on the East Coast in the summer, oh my gosh, it's hot and humid. And it's this current that we have to thank for it being hot and humid, for the humidity. Okay, so if it's summer in our hemisphere, that's what we have to thank for the hot. If you have a warm current running off your coast is going to be more humid. And so what this is doing, you guys remember, this is all about transfer of energy from the areas that have more solar energy to the areas of less solar energy. All right, down here, it's the Eastern Australia current. Where does it go off? It goes off the coast of eastern Australia. Now, this is a little bit more humid here, and you guys, I just saw a TV show. It was Sunday morning on CBS, and they said that the koalas, which eat eucalyptus, are concentrated on the eastern part of Australia. And the first thing that came to my mind is, I know why. It must be the humidity that makes the gum tree or the eucalyptus tree that they eat, you know, thrive on this side, and therefore they would thrive on that side. So I love this stuff. Okay, science is fun. So again, the Gulf Stream. Now these are really important because what they're doing is they're transferring energy. All right, you guys, so once you get up here, you are going to encounter those prevailing westerlies. I'm changing to green, and I'm changing to green only in the northern hemisphere, and this is kind of important. Okay, green means lukewarm. Okay, red means warm. Okay, lukewarm. Now, these are not as hot of currents as you would have here, but they still have some energy. And what's my proof? If I said you have just won a trip to Seattle in British Columbia, or a trip to England to see the royal wedding or something fun like that, you would not pack Arctic survival wear. You would pack rain gear. Okay, but those latitudes are freezing cold. This little bit of heat keeps them from being ice cubes. Instead, it rains a lot, and this ocean current and then the wind current that goes with it, the westerlies, is what brings that energy. And every time it rains on me, I think about, wow, I'm having energy released on me. Because remember that energy is absorbed through evaporation in the evaporative latitudes, and then when it rains, that energy is released, and it's released in these higher latitude places. This stuff's cool. All right, now really simply, guys, this is the North Pacific Ocean. This is the North Pacific Current. Okay, and this is the North Atlantic Ocean, and hey, this is the North Atlantic Current. It's really not that bad. Now, I'm putting down the green, and I'm picking up the blue. Why? Because something weird happens down here. Remember this. This is where the only place on Earth where we have an ocean current go all the way around the Earth. Now, it has two different words. It's called the west wind drift. Okay, but another one is the circum-Antarctic polar current. So either one I will take. But the circum-Antarctic polar current goes all the way around Antarctica. And in fact, it's what makes Antarctica so darn icy. When plate tectonics pulled these guys apart about, I don't know, 24 million years ago. I'm guessing it's somewhere around 24 to 28 million years ago. It pulled the tip of South America and this little part of Antarctica part. That's when we established the circum-Antarctic polar current. And this is a very effective block to heat transfer. And because of that, over the last 24 million years or so, we have built up huge amounts of ice here. Kind of give you guys a bad analogy. When you're learning to drive, let's say this was a freeway and everybody's going like 80 miles an hour, and here you are trying to come on a really short off-ramp. It just doesn't work. And so, yeah, warm water comes down here, but boy, this icy blast just dissipates it. So this is not lukewarm. Okay, and in fact, we got lots of glaciers down here. If it was lukewarm, this would be rainy, kind of like England or, Seattle. All right. Now, again, we're going to pile water up, pile water up, pile water up. And we're going to move it down. And again, that's a deflection to the right in the northern hemisphere. Flip it around if you don't believe me. A deflection to the right in the northern hemisphere, and a deflection to the left in the southern hemisphere. You guys, have you ever been swimming in the summer off the coast? It's still freezing. And it's still freezing. This is called the California, hey, this is easy, California current. Our water off our coast is really cold for two reasons. We got a cold water current moving by, and then we also have coastal upwelling. The best fishery in the world is this Chile-Peru, the Chile-Peru current. And, not only is this area right off here is the best fisheries, they also have a cold current, and they also have that coastal upwelling. And so, we get a payoff. We have good fishing because of the cold water. It keeps the base of the food chain happy. Cold, nutrient-rich water comes from deep or intermediate waters up to the surface, so that base of the food chain is really happy. And then, with the base of the food chain's happy, usually the rest of the food chain's happy, which means that you happily go to your sushi bar to get some good stuff. But that's the California current, that's the Chile, Peru. And now this one's called the Canary Current. Right off here, we have the Canary Islands off the coast of Africa, and I think they're owned by Spain. They're a Spanish colony, and they are shield volcanoes. They're a hotspot, just like Hawaii is. And so that's named the Canary Current because it goes off by the Canary Islands. So the names are typically what's it going by. So again, you guys, download a couple extra of these, just practice, because I don't know, in 5 minutes I could learn this. These names are pretty easy. Now, I didn't make you learn the other subtropical gyres because those names don't mean anything to you. Benguela, Algulis. I mean, these are kind of crazy names, but these are pretty easy names. So I don't feel too bad about making you learn these. So these are my ocean surface currents. Okay.